Okay, students, we got the spiral quizzes that will prepare us for the air test. All right, so let's just jump in Unit 1, graph the points. All right, so we're not going to do that just to save time. Actually, we will. Isosceles triangle JKL has a perimeter of 32 units and the given vertices. All right, so let's go to Desmos. All right, so if we just plot these points, we plot -3, 9, and -3, 6. Oops. All right, we're going to realize something. Oh, excuse me, -3, -9. All right, so getting this far, some things we got to realize is that isosceles means two equal sides. By plotting this point and this point, and we can count over here that these dots are 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15 apart. All right, since we know that the length of JK is 15, we need to find a possible x coordinate for the point L. All right, so it just gives us half the coordinate. It says L's at x, comma -1.5. All right, so we don't know what that value is for x. We can't even plot that into Desmos, but what we can do is do this. We can say, well, KL has to equal 15, and while we're at it, we're going to use the distance formula. And remember, this distance formula is given to you on the air test. All right, we just have to use our resources. All right, so just plugging and chugging from here. All right, that's 15. Doesn't matter which one's which. I'll just call this x sub 2, y sub 2. K gets to be x1, y1. So we'll have the giant square root of x minus -3, so x plus 3 squared, plus y sub 2 is -1.5, and then 6. So we're subtracting that, and we got this. Okay, so a lot happened really fast. We plotted 2 points, figured out the side was 15, so the other side has to be 15 since it's an isosceles triangle, and then we have all this math that happened. All right, action-packed stuff. All right, we just then plugged it into the distance formula. All right, and then to hack test mode Desmos, just set both sides equal to y. So y equals 15 and y equals giant square root, all that junk. All right, let's plug that into Desmos and find the intersection. All right, so crazy things are happening, and we're going to round a little bit, because then once we plug this into Desmos, we realize that we got a 9.99 comma 15. We're just going to round and say that x would equal 10. Smiley face. All right, so we can turn a really hard problem into an easy one by using Desmos as much as possible and using the given formulas. All right. This one right here is the diagram shown where K is parallel L and M is a transversal. Move the statements and reasons to the table to prove that angle 1 is congruent to angle 5. All right, so this really dictates our thinking. What do I mean by that? Well, we're given all 4 cluster of angles down in the bottom, but only 2 angles in the cluster up top. All right, so we're given that the lines are parallel. So a lot of these theorems we know are true now. All right. So first off, we got to identify corresponding angles that are congruent. All right, and then what we also need to do, so it's 1 and 3. 1's congruent to 3 because they're corresponding angles, and then 4 is congruent to 6 because they're corresponding angles. How do we know which one to pick? Well, we got to use what's called reverse engineer. Okay. In my final statement, I want to prove that angle 1 is congruent to angle 5. So when I'm picking corresponding angles are congruent, that means I'm going to pick 1 and 3. Why? I need a 1 in my final answer. All right. although 4 and 6 are congruent, it won't help me get to my final destination. That's why I picked those ones. All right. Now next, this is something that's got to be free points. We've practiced this a billion times. Is we have this here. All right, we talked about angle 3. Well, what else do we know about angle 3? Well, really, it's only congruency we're allowed to pick. All right, so like 3 is congruent to 5, is 3 congruent to 4, is 2 congruent to 3. Those are all possible choices, and we're actually going to pick this one right here. We're going to pick 3 is congruent to 5. Why are we going to pick that? Well, if you look at it, they're vertical angles, and it's reverse engineering. I can talk about angle 3. I've talked about it in step 2, and in my next step I need to talk about angle 5, so I might as well talk about it now. And we really just have to know that this is true because they're vertical angles. All right, so cross that out, cross that out. All right, and then really my last one's just going to be, well, how do I know angle 1 is congruent to angle 5? So it's going to be one of these statements down here, or excuse me, reasons. All right, is it transitive property, symmetric property, so on and so forth? Well, at this point in time, we really just got to know that since angle 1 is congruent to angle 3 is congruent to angle 5, that angle 1 is congruent to angle 5 by the transitive property. All right, just stuff we got to know. All right, and that's it, that easy. So basically all you have to do is identify corresponding angles, vertical angles, and remember the transitive property. Not too bad. All right, number 3, triangle EFG is congruent to triangle JKL. All right, so that means EF, this side right here, JK, is congruent to that side. I mean, excuse me, this side right here. Almost brain fart, JK. All right, JK and FE, so that means that that's 4. FG, which is this side here, KL, boom. And that's what it's asking for. What is KL in units? Well, since that's 6, this must also be 6 as well.